Planet Earth is the home of every life form known to us in the universe. Its age is about a third of the age of the universe, and, admit it, it is a thing of beauty. A slightly squashed sphere with a heavy metal core and a lighter surface crust wrapped in a thin sliver of sweet air to breathe, with vast oceans, fertile plains, magnificent mountains, freshwater rivers, streams, lakes and aquifers, orbiting a star which warms us and gives us energy. But how did our home come into existence, and what's it made of? The Earth cooled down and the surface formed a thin crust. But inside the Earth, hot rock continued to swirl about, moving the crust from below and breaking it apart. This process is called plate tectonics and is happening right now. We'll make a whole video about it in the future. For now, let's just say that the crust of Earth consists of separate giant plates that move around. As they meet, they crumble and create mighty mountains, or violently plunge back down deeper into Earth, creating deep trenches. That's the way the highest place on Earth was formed, Mount Everest, and the deepest, the Mariana Trench. From our perspective, Earth's mountains and trenches are mighty indeed, but when you look at the Earth in cross-section, you can see how tiny they actually are. The part we stand on is the crust, which is about 50 kilometers thick, though it can vary between 5 and 70 kilometers. By the way, the deepest hole ever drilled by man is 12.262 kilometers deep. After the crust comes the mantle. It's a silicate rocky shell and about 2,900 kilometers thick. The mantle consists of the upper mantle and the lower mantle. The upper mantle has different regions too. Its upper part, which is viscous and carries the crust, is called the lithosphere. After that, there comes the asthenosphere, which consists of less mobile, mostly solid material. The lower mantle reaches deep down to the outer core of Earth. Earth's outer core is a liquid layer of iron and nickel, about 2,266 kilometers thick. Temperatures vary from 4,000 degrees Celsius to 5,700 degrees Celsius. And in the center is the inner core. It's mostly solid, a ball made of an iron-nickel alloy, with a radius of about 1,200 kilometers, 70% the size of the Moon, and about the temperature of the surface of the Sun. It is slowly growing at an estimated rate of about 1 millimeter per year. Now for some perspective. This small layer of crystallized milk products of former molten mantle
Our planet has a violent soul. Majestic and often destructive, volcanic explosions rattle our collective imagination. Krakatoa, Mount St. Helens, Etna, Eyjafjallajökull, the images simultaneously strike fear and awe in our hearts. But how did these giant mountains form, and where does all that destructive force come from? At least 50 eruptions rock the Earth each year, meaning our planet is literally bursting apart at the seams. The Earth's crust is made up of about 17 slabs of land called tectonic plates that float on the superheated magma that makes up most of the planet's interior. Magma is the Earth's lifeblood, churning restlessly beneath the crust. And wherever it can, it's trying to burst through. It's at these spots that volcanoes form. Our planet is home to some 500 active volcanoes. While some volcanoes, like those in Hawaii, break through a thin point in the crust called a hotspot, the vast majority of volcanoes occur on active fault lines where tectonic plates meet. The most volatile region is the Ring of Fire, a geological fault belt that rims the Pacific Ocean and holds roughly 75% of all the Earth's volcanoes. Typically, volcanoes take one of two forms. Shield volcanoes, wide and broad with lava usually slowly oozing out of them, and composite or stratovolcanoes, steeper and more violent. When hot liquid magma reaches the surface, whether in a slithering flow or a booming eruption, we call it lava. Though molten lava may seem threatening, it's not known to move quickly. A volcano's pyroclastic flow is far more deadly. This poisonous ash cloud can race down the slope of a volcano like a bullet train, obliterating everything in its path at speeds topping 100 miles per hour. It's what stopped the residents of Pompeii dead in their tracks. But despite the volcano's brutal destruction, it is also a force of beauty and rebirth for the planet. Lava creates new lands where life can flourish. Like it or not, volcanoes are part of the planet's life cycle. As the Earth continues to explode, gurgle, and slither its molten heart out, we must learn to live side by side with its awesome power. The ground starts to quiver, glasses rattle. Soon, walls shift and everything begins to collapse. Telltale signs of what could be a devastating earthquake. We've seen the destruction they unleash. Some of us may have even lived through one. And we know they can be deadly. But where does this mountain-moving force come from? While we may think we're standing on solid ground, the Earth beneath us isn't completely stable at all. Our planet's crust is made up of about 12 major tectonic plates that fit together like a giant jigsaw puzzle. These huge slabs of land float on superheated magma and constantly shift, bump, and grind against one another. It's there, along the seams, where earthquakes tend to happen. When friction between the two plates is violent enough, seismic shockwaves ripple through the ground, rattling everything that stands on it. The stronger and shallower the quake, the more violent the destruction. The most violent type of earthquake is born in a subduction zone, where one tectonic plate is shoved beneath another. While one plate is forced downward into the mantle, the other juts upward, often violently. This is the type of quake that rocked Nepal in May 2015. And when subduction happens under the ocean, it can create giant, unstoppable waves called tsunamis, like the ones that killed hundreds of thousands in Japan and Indonesia. On average, earthquakes kill about 10,000 people each year. Sometimes numbers are far higher. The quake that hit Haiti in 2010 killed more than 300,000 by some counts, making it one of the deadliest on record. It is estimated that there are 500,000 detectable earthquakes in the world each year. 100,000 of these can be felt, and 100 of them cause damage. That's about 0.1%. The magnitude of an earthquake is measured using the Richter scale, which runs from 0 to 10, 10 being the strongest. Every whole number increase on the scale means 10 times more ground motion change. In recorded history, the world has never experienced a 10 on the Richter scale, but scientists predict an average of at least one major quake of magnitude 8 or higher every year. The fact is, the Earth's crust is restless and always on the move. We can't see earthquakes coming, but we can prepare for them. Engineers are now designing stronger buildings, resilient enough to survive a direct hit. Scientists are crunching data to project the power of future quakes and anticipate when and where they can strike next. Right now, we can only estimate the probability an earthquake will occur, but perhaps one day we will learn to predict them, minimizing their destruction and saving countless lives.